This video deals with the addition and subtraction of algebraic fractions. At first, we're going to consider fractions which have a common denominator. Take for instance this expression. You see a fraction a over c whose numerator is a and whose denominator is c. We have another fraction b over c. The numerator is b and the denominator term is c. These two fractions have a common denominator, and for fractions of this form, addition is carried out as follows. A plus b divided by c. So what did I do? Or what's the rule? Well, when adding two fractions which have a common denominator, the result is a fraction whose denominator is the same as that of the original fractions and whose numerator is obtained by just carrying out the operation in the order you see it. So for instance, in this case, the denominator of the resulting fraction is the same as the denominator of the original fractions. The numerator of the resulting fraction is given by a plus b. You basically just pick the numerator of the first fraction, then observe the sign, note it down, and you pick the numerator of the second fraction. And it's as simple as this. For example, 1 over 2 plus 3 over 2 is equal to a fraction whose denominator is the same as that of the original fractions because they have a common denominator, and whose numerator term is given by 1 plus 3. 1 plus 3 equals 4 over 2. So let's move on to another expression. Again, we have here fractions which share a common denominator. Here the common denominator is d. So the resultant fraction has the same denominator as the original fractions, and the numerator of the resultant fraction is given by a plus b plus c. So a plus b plus c. A plus b plus c. For example, 4 over 5 plus 3 over 5 plus 2 over 5 is equal to what? A fraction whose denominator is the same as the denominator of any of the original fractions, and whose numerator is given by 4 plus 3 plus 2, which is equal to 7 plus 2, which is 9 divided by 5. Here's another example. We have two fractions with the same denominator, so we automatically know that regardless of whatever the operation is, the denominator of the resulting fraction is the same. It's going to be c. The numerator of the resulting fraction is given by a minus b, and that's it. So the addition and subtraction of fractions which share a common denominator, it's an easy process. For example, if we had 6 over 7 minus 2 over 7, we would easily know that the resulting fraction has the same denominator, and the numerator is 6 minus 2. 6 minus 2, which is 4 over 7. So it's very easy. Here's another example. These three fractions, a over d, b over d, and c over d, share a common denominator. So the result of the operations here, because we have a over d minus b over d minus c over d, is easily given by the following. The resultant fraction has the same denominator as the denominators of the original fractions, because all of these fractions share a common denominator d. The numerator of the resultant fraction is given by a minus b minus c. A minus b minus c. So for example, if you had the fractions x over 2 minus 1 over 2 minus 3y over 2, the result will simply be a fraction whose denominator is the same as the denominators of the original fractions and whose numerator is given by x minus 1 minus 3y. It's as simple as this. So I'll just put this in a bracket. Here's one more example. We have three fractions. They share the common denominator d. So the following operation gives rise to a fraction whose denominator is the same as the denominator of any of the original fractions, d, and the numerator of this resulting fraction is given by a plus b minus c. So for example, 4 over 7 plus 2 over 7 minus 3 over 7 is equal to what? A fraction whose denominator is the same as the denominator of any of the original fractions, so 7, and whose numerator is given by 4 plus 2 minus 3. 4 plus 2 minus 3, which is 6 minus 3, which is 3, as the numerator, denominator is 7. And that's it for fractions which share a common denominator. That's it for the addition and subtraction of fractions which share a common denominator. The next thing we need to consider is how to add and subtract fractions which have different denominators. In this situation, what you do is you reduce the problem to one which involves the addition or subtraction, or addition and subtraction of fractions which have the same denominator. So you go from fractions with different denominators to fractions with the same denominator, because as you've just seen, the addition and subtraction of fractions which have a common denominator is an easy process. So here we have a over b plus c over d. A over b is a fraction and c over d is a fraction. They have different denominators. The denominator of the first one is b and denominator of the other fraction is d. So how do we proceed? We proceed by manipulating these fractions to give fractions that have the same denominator. So here's what you do. You take the first fraction and you multiply it through by the denominator of the second fraction, which is d. So the first fraction is a over b, and you multiply it through by the denominator of the second fraction, multiplying it through by the denominator of the second fraction, d. So that means multiplying the numerator of the first fraction by d and the denominator of the first fraction by d as well. Then you note the sign. Then you take the second fraction, c over d, and you multiply it through by the denominator of the first fraction, which is b. So we're going to multiply the second fraction's numerator by b, and we're going to multiply the second fraction's denominator by b as well. And doing this gives a d over b d plus cb over db. So you can ignore this for now, which is equal to AD over BD plus CB over BD, because this DB is the same as BD. So I'll show you again. A times B is equal to B times A. When you're multiplying two terms, the order in which the multiplication is carried out does not matter. When you're multiplying two or more terms, so B times D is the same thing as D times B. So in this case we have DB, which is D times B. We're saying it's the same as B times D. So D times B, which is DB, is the same thing as B times D, which is BD. So we change DB to BDY so that we can have the denominators looking exactly alike. Now that we have two fractions which share a common denominator, all we have to do is say, well, the addition of these two fractions results in a fraction whose denominator is the same as the denominator of any of the original fractions, and whose numerator is given by AD plus CB. AD plus CB. And that's it. So for example, let's take an example. 3 over 2 plus 4 over 5 is given by what? Well, to do this, you note that the fractions here have different denominators, so we need to reduce the problem to an addition problem involving fractions with the same denominator, because we know how to solve those kind of problems. So what you do is you take the first fraction, 3 over 2, and you multiply its numerator and denominator by the denominator of the second fraction, which is 5. You note down the operation, which is plus in this case, and you take the second fraction and you multiply it through by the denominator of the first fraction, which is 2. This gives 3 times 5, 15, 2 times 5, 10, plus 4 times 2, 8, 5 times 2 is 10. Now we have two fractions with the same denominator, so addition of these two fractions results in a fraction whose denominator is the same as their denominator, 10, and whose numerator is given by 15 plus 8. 15 plus 8, which is 23 over 10. So we just looked at the addition of two fractions which have different denominators. Now, next we're going to look at the subtraction of a fraction from another fraction where both fractions have different denominators. So this case, which I crossed out, so I'm going to write this here. How do you simplify a problem of the form a over b minus c over d? We do the same thing. These fractions have different denominators. So we're going to reduce the problem to a subtraction problem involving fractions with the same denominator because such problems are easy to solve. The way to achieve this is to take the first fraction and multiply it through by the denominator of the second fraction, d. Note down the operation, here it's a minus. Then take the second fraction and multiply it through by the denominator of the first fraction. Simplifying gives AD over BD minus CB over DB, which is the same thing as AD over BD minus CB over BD. D times B is the same thing as B times D. Now we have two fractions with the same denominator term, so we know that this subtraction problem results in a fraction whose denominator is BD, the same as the denominators of the original fractions, and whose numerator term is given by AD minus CB. So for example, we have the operation 8 over 5 minus 2 over 3. The way to solve this subtraction problem is to take the first fraction, multiply it by the denominator, multiply it through by the denominator of the second fraction, which is 3. Note down the operation, take the second fraction and multiply it through by denominator of the first fraction. And you simplify. 8 times 3 is 24, 5 times 3 is 15, 2 times 5 is 10, 3 times 5 is 15. Now we have a subtraction problem involving two fractions with the same denominator. We know that this gives us a fraction whose denominator is the same as theirs, 15, and whose numerator is given by 24 minus 10, which is 14 over 15. And that's it for the addition and subtraction of fractions. Let's quickly go through some examples of problems involving the addition and subtraction of algebraic fractions. Here we have 1 over x minus 3 over z. We have two fractions with different denominators. So what do we do to simplify this problem? We take the first fraction and multiply it through by the denominator of the second fraction. And we note the mathematical operation. Now take the second fraction and multiply it through by the denominator of the first fraction. This gives z over xz minus 3x over zx, which is the same thing as xz. And this simplifies to give a fraction whose denominator is xz and whose numerator is z minus 3x. As you can see, we have two fractions with whose denominators are the same. We started with two fractions who had different denominators. So now to the next example. This time we have three fractions and none of them share a denominator. None of them have a common denominator. So we can break this problem down into the following. We focus on this addition, then we add this result to this fraction. So just focusing on this expression, 2 over x plus 3 over y can be simplified by taking the first fraction and multiplying it through by the denominator of the second fraction. Noting the operation, taking the second fraction and multiplying it through by the denominator of the first fraction, which gives 2y over xy plus 3x over yx, which is the same thing as xy. And this simplifies to give a fraction whose numerator is 2y plus 3x and whose denominator is xy. Note that the denominators have the same. The denominators of these two fractions are the same. So now we know that 2 over x plus 3 over y, 2 over x plus 3 over y is this expression here. So we can now replace this expression with this expression. And that doing so gives 2y plus 3x over xy that's this expression, plus 4 over z. So this original expression is this expression here. Now we're just focusing on the addition of two fractions which have different denominators. The denominator of the first fraction is xy, the denominator of the second fraction is z. So what do? We take the first fraction, 2y plus 3x over xy, and we multiply it through by the denominator of the second fraction, which is z. We note down the mathematical operation. We take the second fraction and multiply it through by the denominator of the first fraction, which is xy. Simplifying gives 2y plus 3x z over xyz, xy times z is xyz, plus 4xy divided by zxy. Now note, zxy is z times x times y, which is the same thing as x times y times z, because the order in which the multiplication is carried out doesn't matter when we're just talking about multiplication of expressions or terms. And x times y times z is the same thing as x, y, z. So zxy is xyz. So we now have 2y plus 3x times z or xyz plus 4xy over xyz. Now we have two fractions, one fraction, second fraction. So let me highlight them. This is one fraction, this is another fraction, and they have the same denominator of xyz. So now we can easily solve this problem because the addition of these two fractions gives a fraction whose denominator is the same and whose numerator is given by this term plus that term. So 2y plus 3x z plus 4xy. This term, 2y plus 3x times z, is the same thing as z times 2y plus 3x. So we can write this term differently. We can expand this expression to give z times 2y, which is 2zy or 2yz, and z, noting a plus sign, and z times this second term within the bracketed expression is z times 3x, which is 3xz, plus 4xy over xyz. And this is the result. Here's another example. This is a problem which involves the subtraction of an algebraic fraction from another algebraic term. Now x minus y over z can be written as x over 1 minus y over z, because x is the same thing as x over 1. So now we have a subtraction problem involving two fractions. These fractions have different denominators. The first fraction has a denominator of 1. The second fraction has a denominator of z. So now we need to reduce this subtraction problem to one which involves two fractions with the same denominator, and we achieve this by taking the first fraction and multiplying it through, so this first fraction, multiplying it through by the denominator of the second fraction. Note down the operation. We take the second fraction and multiply it through by the denominator of the first fraction, which is 1. And simplifying gives xz over 1 times z is z, minus y times 1, y, z times 1, z. Now we have two fractions with the same denominator, so we know the result is a fraction whose denominator is z, the same, and whose numerator is given by xz minus y. And we're done. Here's a final example, and it's more like what you'll find in an exam. It's more of an exam standard question. So we have the addition of two fractions. Here's the first fraction, 1 over x plus 1. The second fraction is 1 divided by x minus 3. The denominator of the first fraction is this x plus 1 term. The denominator of the second fraction is this x minus 3 term. They are different from each other. So we have a problem which is the addition of two fractions which have different denominators. The way to solve such problems is to reduce the problem to an addition problem involving two fractions which have a common denominator. And the way to achieve this is to take the first fraction, 1 over x plus 1, and multiply it through by the denominator of the second fraction. The operation is then noted, and then you take the second fraction, 1 over x minus 3, and you multiply it through by the denominator of the first fraction, which is x plus 1. And then we simplify. 1 times anything is that thing. So 1 times x minus 3 is x minus 3. Our denominator is x plus 1 times x minus 3. X plus 1 times x minus 3. That's what this is. Note the addition sign. Now the next expression, the numerator is 1 times x plus 1. Now 1 times any term is that term. So 1 times x plus 1 is x plus 1. So I'm going to put this in the bracket. I'm also going to put this in the bracket. The denominator, x minus 3 times x plus 1, is x minus 3 times x plus 1. So this is what we have. So at this point, we know that the first fraction, so I'm going to write it neatly, is x minus 3 divided by x plus 1, x minus 3, plus x plus 1 divided by, well, what's x minus 3 times x plus 1? It's the same thing as x plus 1 times x minus 3. Remember, when you're multiplying two terms, the order in which you multiply doesn't matter. And all of a sudden, you can see that this denominator term is the same as this denominator term. So that's x minus 3, which means that we now have an addition problem of two fractions which have a common denominator. And for these problems, you know that the resulting fraction has a denominator equal to the denominator of any of the original fractions, and a numerator which is given by x minus 3 plus x plus 1. And this can be simplified further, because if we drop the bracket of the numerator term, we have x minus 3, we have plus times x is plus x, and we have a plus, and then we have plus times plus 1 is plus 1. And the numerator, by grouping like terms or swapping the position of minus 3 and x, we have x plus x minus 3 plus 1 as the numerator. We have x plus 1 x minus 3. So we have 2x minus 3 plus 1 is minus 2 divided by x plus 1 times x minus 3. And this is the simplified version of what we started with, this version here.